Okay, I'm taking a look at number 6 from the review one more time. Just to kind of slow it down and make sure people are understanding what's happening here. All right, so here's the chain that you have to consider. If the following, well, let's do this before we get to the if. Let's let g of x equal to 1 minus x squared. Okay, so if I do that, if the limit as x approaches 0 from the left of g of x is equal to the limit as x approaches 0 from the right of g of x, then this value, whatever it is, we're going to define that as the limit as x approaches 0 of g of x. So if the left-hand limit and the right-hand limit agree, so if we can get that equal sign, then this equal sign must be true, which means that the limit in turn as x approaches 0 of f of 1 minus x squared has to be equal to this, because this is how we defined g. Okay, so if you buy that set of equations, what I need to do is I need to find the value of this, I need to find the value of this, and if they're equal, I'm done, and that will be the value that I want here. Okay, so let's investigate this first. What is the limit as x approaches 0 from the left of g of x? Okay, note, g of x is equal to 1 minus x squared. That value is always less than 1 when I have a number that is to the left of 0. Okay, so let that catch up for a second. This number is always going to be less than 1, which means that if I am approaching 0 from the left, this also has to be approaching 1 from the left, because this is always less than 1. Okay, so this gets me that this limit here, the limit as x approaches 0 from the left of g of x, is the same as the limit as x approaches 1 from the left of f of x. Okay, because as this is approaching 0, g is approaching 0, right? F, this piece, is going to be approaching 1, but because it's always less than 1, it has to be doing it from below. So let's take a look at our graph. And if I look, here's 1. I am approaching 1 from below. If I'm approaching 1 from below, I am approaching 3. So this value is 3. Okay, so that argument gets me this, right? So we now have that this is equal to 3. Okay, so now we have to look at this piece. What is the limit as x approaches 0 from the positive side of g of x? But recall, 1 minus x squared is always less than 1 when we're approaching 0. If I'm approaching it from the positive side, 1 minus x squared is still always less than 1, which means that this is the same as the limit as x approaches 1 from the negative side. Why is it from the negative side? Because this expression is always less than 1. Can't approach 1 from the positive side if it can't be more than 1. Okay, so of f of x, so let's look at what's going on here. If I'm approaching 0 from the negative side, so I'm approaching 1, still here, still approaching from the negative side, which means I am still approaching 3. So this must also be 3. So if this is 3 and this is 3, we've come to an agreement that if these two are equal, which in fact they are, they're both equal to 3, then this has to equal 3, because if the left-hand limit is 3 and the right-handed limit is 3, the limit exists and the limit is 3. Now, because we define g of x as this, I take out the g of x, I put in 1 minus x, which means this guy is also 3. 3. Can't be anything else, because this is 3, this is 3, which means this is 3, and since these are equal means this is 3. So looking at the problem from the review packet, I am picking C, and that's my story, and I'm sticking to it.